Hello, welcome to our channel for rprogramming for statistics. In this video, we will talk about how to evaluate the relative importance of variables in regression using approach called relative weights. And we use rprogramming for this kind of data analysis. So in regression, usually we want to ask which variables are most important in predicting the outcome. And if the variables are not correlated with each other, so it's quite simple. We just can measure the correlation between each variable and each explanatory variable and outcome variable. But in reality, it's not possible because most of the variables are somewhat more or less correlated with one another. So it's a little complicated. We can measure and we will show what's the relative importance of each variable in regression. So there are several approaches, and one approach is called relative weights. So this means we will show the average increase in R square. The R square is the coefficients of determination in linear regression. So we will show what's the contribution of each variables in R square from all possible submodules, because in the one module, the relative weights or their contribution in R square may not the same with other modules. So we have to evaluate all the submodules. And next we will show an example using this approach in RStudio. So first we have to create a function called real weights. And this function is mathematically calculates the relative contribution. So the relative contribution in estimating, explaining the variance or the coefficients of determination of outcome variables for each independent variable. So we just run and create this function first. So next we will create a data frame called states. So this data frame actually including five variables from a matrix called state.x77 in R. So we just show this data frame. So there are 50 observations with 5 variables: the murder, population, illiteracy, income, and frost. These 5 variables for 50 states in America. So say we want to create linear regression module to explain the murder rates by using these other 4 variables as independent variables. So we just use the lm function in R, and the result of the linear regression will be assigned to an object called fit. So if we just print a fit, it will show coefficients of each variable. But this fit includes many important information, but the summary default is just shows these coefficients. So next we can call this function called real weights by passing fit objects, and we set the color. Just forget it, and we will just fit input. Then you can see the result is R square is about 0.5669. So this is the part of the variation of the outcome variable I explained by the module, by the 4 independent variables included in the module. And the next part of the result from this function is for each independent variable, there is a column And this column represents the percentage. So their total 100% percentage and divided by for each variables. And for example, income just only contributes 5% of the coefficient of determination, and population is about 14%. So the biggest contribution from this module, from all the sub-modules, is this variable, illiteracy, and which contributes about 60% of the coefficient of determination of this outcome variable. Thanks for watching.